Hi, my name is Rajesh Valuri. Welcome to my video. In this video, I would like to go through a process where you can download images for training your image processing models, and also how to pre-process them before you actually can use them in a training exercise. So, just a bit of context is a few months ago, I have done a project where I used .NET based YOLO 4 model, YOLO version 4 model to train. A few months ago, I made a video where I showed how to run your own .NET based YOLO 4 model on Google's Colab, and I have also shown you in that video how to use that model to test images of your own to see what objects are present in them. To those who don't know this, don't know YOLO, YOLO, you only look once model, and in general the .NET model. .NET is created by Alexei, and it was a state-of-the-art image recognition object detection model, and it's open source. And what I'm doing now is actually showing you a use case of that model, a real world use case of that model. Shortly after that video was made, I actually did a project where I trained a machine learning model, a YOLO model, to look at pictures for any picture and identify if there are any birds in it, and then what bird that it is. So the motivation for this project was, I live in a house with a beautiful backyard, and then it attracts a bunch of different species of birds every single day. Some of the birds are quite popular and are well known to people, like this one you see, rainbow lorikeet it's called. And yeah, these are really pretty, beautiful looking birds. However, this guy on your screen right now is a kookaburra, which apparently is quite as popular in Australia, but I did not know about that one. So one day I came to the backyard and I saw this guy sitting there, and I didn't know what that bird species is. It looked majestic. It was amazing, but I just didn't know what it's called. So I took a picture of this, posted it on Facebook, and then people said, "Yeah, this is what it is." Blah blah blah. Then something clicked in my head, and I wanted to do this as an experiment, as a proof of concept. Take pictures of birds and run them through the model and see if the model can pick it up. So that was quite successful. I ended up building it with six different bird species that come to my backyard. Obviously, you can add as many or as few species you want, but the idea was to do this as a proof of concept and see if there are any use cases for it. So a real world application for this would be livestock management. Most farmers use dogs and other things to look after their livestock, for example. But they also have these predators that occasionally jump through the fences and then kill cows and sheep and other stuff. So a typical use case could be that they install these webcams on the perimeter of the farm, and every time there is a predatory animal or a bird lurking, then the system takes a picture, processes it, and finds this. And then as soon as it finds, let's say, a not tiger but like a wild dog or something, it will just send an alert to the farmer. Another use case would be for scientists who are looking for a specific bird or an animal which they think could be going extinct, or could be a invasive species that should not be in that area. They can use these cameras. Instead of doing it manually, they can just outsource this grunt work to a machine. So yeah, that's the end goal. So I wanted to break this into three different videos. The first video deals with downloading training images and pre-processing them. The second video would be the actual training process itself, where you upload these pictures and the label files to Google's Colab and train your model. And then the final process is the final step is actually to build that application around this model, which I want to do it in Raspberry Pi and a couple of webcams attached to the Pi, and then send out emails and SMS alerts. But so that's the third and the last part of it. But in this video, I would just like to keep it simple. This video itself deals with downloading a bunch of images from Google and then creating bounding boxes around them. The bounding boxes are like this around each thing, each bird or whatever that you'd like to train your model on. And then the label file will contain information about this bounding box. So for example, in this picture, the label file will say there is the starting coordinate of this bounding box is this here, and the ending coordinate is this, and the object contained in that box is blah blah blah. So that you have to do this for all kind of every image in your training set, and then use that training set to train. So so the first step, like I said, is once you decide on what your training model what your model does, like is it picking up birds from a photo or animals or different kinds of fruit or anything of your choice. Just need to download to decide on how many different kinds of things that. So let's say if you're doing apples. I don't know, I'm not a apple farmer, but some farmers can look at an apple from a distance and say, okay, this is this, blah blah blah. So if you want to do that, you have to have, let's say, 4 different kinds of apples. So you need to have about, give or take, 100 different pictures of each of those apples taken from different angles. In my example, I'm taking pictures of birds. Like I decided to do, like I said, 6. I don't remember, 5 or 6. So I need to have 100 images, close, give or take, of each of those bird types. So first thing, decide on what you're going to detect, and decide on how many number of pictures you would like, and be mindful that the more classes of things that you're identifying, the more obviously the number of pictures you should be downloading, and then pre-processing, which is actually the pre-processing is the most tedious and manual part of this all, because there's no automated way to do it. So you have to suck it up and do it. To me, it took me like a week just to go through it, because I also have a full-time job. So I was doing this between like when I can find some free time. So that's the most manual and tedious part. And then comes the actual training itself, which Colab on free version of Colab could take up to 2 or 3 days. And then you have to write code and do the third the application part of it, which we'll deal with it later. So okay, so how do we download images? The easiest way is to obviously go with Google. Google has like when you type in Google, yeah, there's a bunch of images that pop up, and then so I'm using this this Chrome extension called Download All Images, and this is fairly straightforward to use. You can just go to extensions and see what it is, and manage extensions. So it's called Download All Images. So and add to your Chrome browser, and then enter your search term, and then once you see a bunch of pictures, you can just go hover the cursor to this, and then just click on it, and there is a bunch of proper filters that you can apply. So I chose to do the smallest image I wanted is 100 KB, and the highest, the biggest was 2 MB. So that's a typical ballpark of settings, and I just want to limit these pictures to if no extension is present. So I did say no WebP, but I don't know why it still selected them. So if no extension, save as JPEG. I don't want them. And then yeah, let's save these images. I chose the depth as 2, which gives us the second page of search results as well. Save, and it's really fast, but it might take a while depending on how fast your internet is. So saving 136 images, done, and just go to the downloads folder and see here it's lorikeet and the search term base followed by blah 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 and then the date. So let's extract these pictures here and see. Oh, for some reason the WebP format is still showing up. I don't know why, but yeah, let's remove those in the training process. Try to remove those. Try to remove those with the WebP extension. But hang on, why do I have this? Yeah. So unfortunately, you still have to go through all these images and to make sure that image is correct, because Google search results are not always accurate. So in this case, for instance, you can see that it's just the flower, and it's just a flower, and for some reason it came up in the results. So you need to delete those. You need to delete anything that's not a JPEG or a PNG, and then yeah, and then just leave the ones that we could use. This picture is very depressing. I don't want to look at it. It's a bunch of dead birds, unfortunately. I will delete this one as well. And yeah, so this is an incorrect picture, so you need to get rid of that one as well, or you can use it for a different class if you want, if this actually is in one of your classes. But you get the idea. So you collect these images, you make sure that they are the right class, and that's the first step. And then once you do this, you do this of the other bird classes as well. In my case, one of the other classes is cockatoos. I'll show that as an example as well. So these beautiful cockatoos are there, and then I do the same thing here. Go to image, download all images, and then do the same thing at 100 KB, 2 MB, and one picture. But I think it's let the there should be at least figure out 50, 60 in this. So you get the idea. So this will keep going for a while, but I'll just stop here because we don't need to waste time just waiting for those. So 19 images. Come on, should be done soon. I think it has done it. Yeah. So go back here and downloads. There you go. Where is it? Yeah. So here we go. By the way, just made a mistake. So the images are the zip files are found under google.com folder within your downloads folder structure. So downloads, google.com, and then the zip file for each search term. So cockatoos, extract here. Yeah, cockatoos. Yeah, beautiful. So there's 1, there's 2, there's 3, 4. You get the idea. So once you have all of these, now the next step is to use these pictures and to create the training. So pre-process these pictures to create the training data. So the training data, as I alluded to earlier, is each picture and its corresponding label file. So again, to take a picture and create label files, we need to rely on third-party tools. open source third-party tools. And in my case, I decided to go with this beautiful tool called um, labelImg. labelImg is a third-party tool which you can find on GitHub. I think it's made by this guy TJ. I don't know how to say his name. So this is where it is on GitHub. I'll provide this link in the description below. So depending on what system you're using, Windows, Linux like me, or any other flavor, there is instructions on this page on creating, on downloading and installing. In my case, I'm using Mint, which is very similar to Ubuntu. I just had to follow these instructions here. If you run into any difficulties, just Google search it, and then you should be able to get it to work fairly easily. This is a extraordinary tool, and I'm very thankful for this guy making it open source and making it available. So once you have downloaded the image label tool as per the instructions on GitHub, there's a couple things you need to do first. So one of the first things you need to do is to create your predefined classes file, which is already there in the here in the folder data. So you just need to navigate to that folder, and once you look at the file, my file, you'll know what it means, what it does. So it just tells the system, the application, what kind of what different classes of images are found in this. So I just have 5: pigeon, lorikeet, magpie, cockatoo, kookaburra. So once you type them in, and then close that file, go one level up. Obviously your application, your file will have the classes that you chose to use. So go one level up, fire up the application using this command, python 3 labelImg, and then it will open up this GUI. And in here, what you need to do is to just make sure that the YOLO format is selected if something else is there. So there can be all these other two ones as well, create ML and Pascal walk. We don't use that in this case, so I'm just sticking to YOLO 4. And then go and fire up open directory, and let's start with see, these are the two folders that we have, cockatoos and lorikeets. Let's start with cockatoos. For some people actually put all the files, like different files in one big folder, and then go with it. But I choose to put them separately, because that way I don't accidentally mislabel images or anything. No, to undo all changes, and no, again, yeah. So see here, these are all the images that we have downloaded, and we just go through each of the images now. So first step is to click on this create box, create rectangle, and do this, and then it will tell you, it will give you an option to pick from the drop down, and then from the select list, sorry, and then do this. When you say next, click next, it says save, yes. This manual process, again, same thing, create rectangular box, make sure that it covers the whole image and nothing more. Keep it as tight as you can, and again cockatoo. So that's 2. I don't want to go through all my images now. I want to try I want to go back to the folder and make sure that it's the annotation files are being created. So let's come here, and this is the lorikeets folder, so we need to go in the cockatoo folder, and yeah, there you go. So this image has a txt file, corresponding txt file. And how many did we do? We have done 2. And there should be one more here. Where is it? Oh, I haven't done the next. I have to do next. Save, and go back to the folder, and then there you go. So let's open up the first one, this image, and corresponding annotations file is here. See, third class, so actually it's the fourth because it starts with a 0, 0, 1, 2, 3, which is and here if you look at this file, where was my annotations file? 0, 1, 2, 3, cockatoo. So the first field points to the class, and then the next set of numbers is actually the left bottom edge and the right top edge. And you can see that these are just fractions, like decimal numbers, less than 1, between 0 and 1. That's because the whole picture is normalized to a 0 to 1, meaning 0, 0 at the top, bottom left, and 1, 1 at the top. So this eliminates the need to actually know the dimensions of each picture. It's just take the full picture and then just say, if you treat it as a 1 by 1, this is where the bounding box begins and ends. That's the first file, and then the second file is this similar. So you need to do this for each of your images in all of your folders, and then it takes a long time, and it's not the most pleasant thing to do. It takes a while, and the more hands you can get to help, the better off you are. I just want to show one other example before we wrap. Let's do a couple of lorikeets as well, and then this one is clearly not a lorikeet, which means I need to delete this from my my training images. The second one, let's go to next image. Yeah, there you go, beautiful. This is a perfect example because this has 3 different birds from the same class in the same picture, and they're all oriented differently. So this is perfect. So let's start with this. The first guy is draw this tight little box and call it a lorikeet. Yes, and then one more, and start here, draw another box, lorikeet, and one last for this picture, for this image, and start here and here, lorikeet. Beautiful. And then next it will save it, and this guy, beautiful, single one image, and one more, beautiful, and lorikeet. Yeah, so you keep doing this for the rest of the images. You make sure that they're all labeled correctly. And the other beautiful thing is, once you have done all of this, you can actually randomly open a few images and to make sure that you haven't made any mistakes. For example, if you go back to the images we have already processed, in this case this guy, and load it up, you can see that there are 3 boxes in here, which means the labelImg tool is loading not just the image but also the annotations file, and it is showing us on the right hand side what we have labeled them. So this is a nice tool, nice way to just spot check a few of the 100 images. Like maybe I'll do 10 or 20 randomly selected images to make sure they're all properly labeled. Yeah, that's about it for this video. So you have downloaded a bunch of images, you have classified them, annotated in image language, image processing lingo, and now you're ready for the next step. So do your thing. If you want to go along and create your own model, or like birds, dogs, flowers, fruits, any number of things, or household objects, try to get to this point, and the next video, the training video, should be available shortly, and then we actually go through the steps of training. So thank you for your time so far, and thanks for sticking with me. And if you have any questions, feedback, or if you have any suggestions on doing these things in a better way, there's obviously always a better way to do things. I used some open source tools. There could be others that you can recommend or you can advise me of. I'm open to suggestions. So please feel free to leave your comments in the comments below, and subscribe and like, and wait for my next video. Thanks for your time. Bye and good luck.